Hi, this is PuyatRanellaGrace Puyat, BS in Information Technology. Today, I will be presenting my course project IT6224 Data Communications and Networking 3. I choose group topic number 1, which are scaling VLANs, STP or Spanning Tree Protocol, and Ether Channel and HSRP. The VTP overview. VLAN Trunking Protocol or VTP allows a network administrator to manage VLANs on a switch configured as a VTP server, while the VTP server distributes and synchronizes VLAN information over trunk links to VTP-enabled switches throughout the switch network. The VTP components are the VTP domain, the VTP advertisement, VTP modes, VTP password, VTP server, VTP client, and VTP transparent. For the VTP domain, it consists of one or more interconnected switches. All switches in a domain share VLAN configuration details using VTP advertisement. Switches that are in different VTP domains do not exchange VTP messages. A router or a layer 3 switch defines the boundary of each domain. The VTP advertisement. The VTP advertisement, each switch is the VTP domain sends periodic global configuration advertisement from each trunk port to a reserved multicast address. Neighboring switches receive this advertisement and update the VTP and VLAN configuration as necessary. While the VTP modes is a switch that can be configured in one or 3 VTP modes: the server, the client, and the transparent. The VTP password switches the VTP domain can also be configured with the password. So these are the 3 VTP modes, which are the VTP server, the VTP client, and the transparent. The VTP server is the default VTP mode. It advertises the VTP domain VLAN information to other VTP-enabled switches in the same VTP domain. It stores the VLAN information for the entire domain in NVRAM. It creates, deletes, or renames the VLANs for the domain. While the VTP client cannot create, change, or delete VLANs. It stores the VLANs information for the entire domain in RAM or random access memory. Must be configured as VTP client. While the VTP transparent does not participate in the VTP except the forward VTP advertisement to VTP clients and VTP server. VLANs that are created, renamed, or deleted on a transparent switches are local to that switch only. Must be configured as VTP transparent. So this is an sample illustration of VTP modes. For example, this is the VTP server, and the second one shows the VTP transparent, and the last one shows the VTP client in the switch network. This is an example of VLAN trunking protocol. So the 3 types of VTP advertisements are the summary advertisements. First, the summary advertisements. VTP server sends summary advertisements to other switches every 5 minutes by default. It includes the current VTP domain and the configuration revision number, VTP version, but does not have VLAN in configuration details. When a switch receives a summary advertisement, it compares the VTP domain to its own VTP domain. But if the name is different, the switch simply ignores the packet. If the name is the same, the switch then compares the configuration revision number to its own revision number. If its own revision number is greater than or equals to the packet is ignored, it is lower that the client will update. The next type is the subset advertisement, which include the details of VLAN information. Follows the summary advertisement. And the last type is the advertisement request. Response to summary and advertisement message when the summary advertisement contains a higher configuration revision number than the current value. When the server hears the request, it will respond to the VTP summary advertisement and the subset advertisement. So these are the two versions of VTP versions, which are the VTP version 1 and the VTP version 2. The VTP version 1 is the default VTP mode on all switches. It supports the normal range of VLANs only. It supports normal range. And then the VTP version 2 also supports the normal range VLANs only, but supports legacy. So it supports advanced feature including unrecognized type length value or TLV, version-dependent transparent mode, and consistency check.
Our next topic is VTP configuration overview. So these are the steps on how to configure the VTP. First, step 1, configure the VTP server. I have here a Cisco Packet Tracer ready and VTP configuration overview. So I have the switch 1, switch 2, switch 3, and switch 4. Switch 1 stands as the VTP server. And we have here the PC1, PC2, and PC3 connected to switch 2, and then PC4, PC5, and PC6 connected to switch 3, and then another switch 4 connected to switch 3. So, it is said that the first step is to configure the VTP server. So, since S1 is the VTP server, let us click the S1. CLI, and then let us enable first, and then enter the configuration mode. Okay, and then let us set the switch 1 to VTP server. VTP mode. Okay, the device mode already a VTP server. And then press N, and then double check to show VTP status. Okay. It is now confirmed that the switch 1 is already the server. And then the next step is to configure the VTP domain name and password. So let us go back to Cisco Packet Tracer. And then since we are going to configure the client, the server domain name, let us click again the switch 1 and then enter the configuration mode. Config T, and then let us set the domain name, let us say CCNA. So VTP domain C domain CCNA. Okay, and then changing the VTP domain name from now to CCNA So it is said that the default the domain name is null, and now it is set with CCNA. Let us now set the password. Password. Let us see Cisco. Okay. Setting the device VLAN database to password. Password to Cisco 12345. Okay, to check, let us exit. Show VTP password. Okay, the VTP password is Cisco 12345. And then, the next step is configure the VTP clients. Okay, the next step is configure the VTP clients. So, for the VTP clients, it is said that the clients are the S2 and S3. So, let us do the S2 client mode. Enable first. And then, enter the configuration. Okay. And then, set this to client. So, VTP mode client. Okay. Setting device to VTP client mode. And now, we are going to configure the domain name. Domain. Let us see, CCNA. Always remember that the domain name of the server must be the same to the domain name of the client. And then now we are going to set the password. So VTP password Cisco. Okay. So setting the device to Cisco, the database password to Cisco 12345. Okay, so let us exit the configuration mode and then check. Password. I show password. Show VTP password, I mean, sorry. Okay. So now the VTP password is Cisco 12345. Okay. After configuring the S2, we are going to repeat the process to S3. So, VTP client. So S3 is now in client mode, and then we are going to set the domain name to CCNA. Okay, and then the password to Cisco. Exit, and then let us check. Show password. Okay, the fourth step is to configure the VLANs on the VTP server. Let us go back to Cisco PuyatRacer and configure the VLAN to the server. Let us enable first. And then enter the configuration mode. And then VLAN 10. So, to VLAN 10, we are going to name the VLAN 10 as sales. So, the command is name sales. Okay. And then, let's see. And then, create a new VLAN 20. So, we are now in VLAN 20. And we are going to name the VLAN 20 as marketing. And then, exit. And then, another VLAN is VLAN 30. And then, we are going to name the VLAN 30 as accounting. Okay. And then, now, we are going to check the status. Show VLAN. Okay. So, we can see that our VLAN 20 is now set to sales. And the VLAN 10 is now set to sales. The VLAN 20 is set to marketing. And 30 to accounting. And then the default VLAN 1 and the ports used. And then now, the next step and the final step is verify the BTP clients have received the new VLAN information. So let's go back to PuyatRanellaGrace. And then let us click the S2. Enable first. And then show status. Okay. CCNA, and this is client. And then show VLAN if. Okay, so we can see that the switch 2 have received the configuration from the server. So it is reflected that there are existing VLAN in the client which we have configured earlier in the server. So the VLAN 10, 20, and 30, which are the sales, marketing, and accounting. So now let us check the same configuration to S3. Yes, enable. So show okay. And then show BTP status. CNA. And then the next topic is will be shown in the next video. Our next topic is VLAN ranges on Catalyst switches. Catalyst 2960 and 3560 series switches support over 4,000 VLANs. For the normal range VLANs, VLAN IDs between 1 and 1005. It is used by small to medium scale enterprise. IDs 1 and 1002 to 1005 cannot be removed and created automatically. Configurations are stored in VLAN .dot, which is stored in flash memory. On the other hand, extended range VLANs, it is used by service provider and large-scale organization for the extension of their infrastructure to a greater number of customers. VLAN IDs are 1005 and 4094. Support fewer VLAN features compared to normal range VLANs. Configurations are saved in running configuration profile. Okay, now I am going to show you how to create VLAN. So earlier we have already created VLAN names. So let us check. So we have VLAN 10 named as sales, VLAN 20 is named as marketing, and VLAN 30 named as accounting. So now we are going to assign ports to each VLANs. So upon checking, we have Fast Ethernet 011 for VLAN 10. Okay, this is assigned to PC1 and PC4. And then Fast Ethernet 018 for VLAN 20. And Fast Ethernet 06 for VLAN 30. So let's start configuring or assigning the ports to VLANs. Okay, to enter first the configuration terminal. Okay, and then interface. Fast Ethernet. So we have Fast Ethernet 011. Okay. This is for VLAN 10. So switch port. Mode access. Okay. Switch port. Access. VLAN 10. Okay. Tama ba? And then end. Oh, let us check. Okay. We can see that the VLAN 10 sales is now assigned to port Fast Ethernet 011. Let us do the rest of the VLANs. So, 50. Let's see. So, sa interface Ethernet 06 for VLAN 30. Let us now check. Okay. It is now assigned to switch 4. Okay, now I'm going to show you how to verify the VLAN information. So let us first check the show VLAN. Okay. And then show VLAN sales. Show VLAN name sales. And show marketing. Or accounting. Okay. Okay, now I am going to show you how to configure extended VLANs. So this is our server, the switch 1. So we are going to configure the extended range VLAN to the server. So by the way, extended range VLANs are identified by a VLAN ID between 1006 and 4094. So, to configure an extended VLAN on the 2960 switch, it must be set on VTP transparent mode. So, let us do that. Go to CLI, enable, and then enter the configuration mode, and then transparent. Okay. Okay. So, setting device to VTP transparent mode. So, let's say that we will assign VLAN 2000 to this switch. So, let us VLAN 2000. Okay. And then let us check. Okay. S1 is now in VLAN transparent mode. And VLAN 2000 in transparent mode. Dynamic Trunking Protocol. DTP is a Cisco proprietary protocol, automatically enabled on Catalyst 2960 and Catalyst 3560 series switches. So, to enable the trunking from a Cisco switch to a device that does not support DTP, we should use the switch port mode and switch port no negotiate. Negotiated interface modes. So, the different trunking modes are the switch port mode access, the switch port mode dynamic auto, switch port mode dynamic desirable, switch port mode trunk, and switch port mode negotiate, non-negotiate. So, for the switch port mode access, it puts the interface or access port into permanent non-trunking mode and negotiates to convert the link into non-trunk link. For the switch port mode dynamic auto, it makes the interface able to convert the link to a trunk link. So for the switch port mode dynamic desirable, makes the interface actively attempt to convert the link to a trunk link. Switch port mode trunk puts the interface into permanent trunking mode and non-negotiate the neighboring link into a trunk link. And the last one, which is the switch port non-negotiate, it prevents the interface from generating DTP frames. Deleting VLANs. Deleting VLANs from a switch that is in the BTP server mode removes the VLAN from all switches in the BTP domain. The default VLANs cannot be deleted. These are the VLANs 1, 1002 to 1005. So, meaning 1002, 1003, 1004, 1005. So, in deleting VLANs, use the no VLAN plus the VLAN ID global configuration mode command to delete a VLAN. For example, we have named the VLAN, a certain VLAN, VLAN 10. So, in order to delete the VLAN 10, use the global configuration no VLAN 10. And then, any ports assigned to the VLAN become inactive. They will remain inactive until assigned to a new VLAN. So, next, I will be showing you the proper way to delete VLANs. The next topic is deleting VLANs. Deleting a VLAN from a switch that is in the BTP server mode removes the VLAN from all the switches in the BTP domain. So, for example, let us first check the existing VLANs in our BTP domain. Okay, BTP, show. So, we have existing VLANs like VLAN 10, 20, 30, and 99. So, now we are going to delete the VLAN 99, which is the management and native. So, in deleting the VLANs, we have first to enter the configuration. Tapos, and then VLAN 99. And then exit. And then let us check again. By typing show VLAN brief. So now, we have already deleted the VLAN 99. Switch port issues. Several common switch configurations can be raised when configuring routing between multiple VLANs. So when using the legacy routing model for inter-VLAN routing, ensure that the switch is properly connected to the router and are configured to the right VLANs. Switch port must be configured to the right VLAN in order for the devices to connect to the router interface. If not, those devices are unable to send data to the other VLANs. So, to verify the switch configuration, the commands are the following. Show interfaces, interface ID, switch port, and the show running config. Let us do this in Cisco Packet Tracer. So, we are going to click the S1, this BTP server. And then, show interfaces has Ethernet. We have F01 switchboard. Okay, so this is the summary report. So it is enabled and said that it is a trunk. Okay. And the trunking native mode VLAN 99 is inactive. Because if you can remember, we have deleted the VLAN 99 earlier. Okay. Interfaces issues. When enabling inter-VLAN router on a router, one of the most common configuration errors is to connect the physical router interface to the wrong switch port. And the other one is with the router on stick configurations. A common problem is assigning the wrong VLAN ID to the sub-interface. Error with IP addresses and subnet mask. So, one common error is for inter-VLAN routing to operate. A router must be connected to all VLANs, either by separate physical interfaces or by sub-interfaces. Each interface or sub-interface must be assigned an IP address that corresponds to the subnet to which it is connected. Next is each PC must be configured with an IP address within the VLAN is assigned to. So, verifying the IP address and subnet mask configuration issues. A common error is to incorrectly configure an IP address for a sub-interface. So, for that, we have to use the show run and show IP interface to verify the IP address. So, another error is incorrectly addressing the end device. So, use ipconfig to verify the address on a Windows PC. So, the common problems with BTP are the incompatible BTP version, the BTP password issue, incorrect BTP domain name, all switches set to client mode, incorrect configuration, and revision numbers. So, the common problems with trunks are the trunk mode mismatches, the allowed VLANs on trunks, and the native VLAN mismatches. For trunk mode mismatches, for example, one trunk port is configured to trunk and the other side is configured to an access port. So, another problem is that both sides are configured in DTP auto mode. So, other mismatches are also possible. So, this configuration error causes the trunk line to stop working and correct situation by shutting down the interface, correcting the DTP mode setting, and re-enabling the interface. So, for the allowed VLANs on trunks, is the disallowed VLANs on trunk has been updated with the current VLAN trunking requirements. So, in this situation, unexpected traffic and no traffic is being sent by over the trunk. Configure the correct VLANs that are allowed on the trunk. So, the last one is the native VLAN mismatches. When native VLAN do not match, the switches will generate informational messages letting you know of the problem. So, ensure that the both sides of the trunk link are using the same VLAN. The same native VLAN. Inter-VLAN routing with switch virtual networks. The illustration shows the 3 layers of a network. So, these are the four layer, the distribution layer, and the access layer. So, in the early days of switch network, switching was fast and routing was slow. Therefore, the layer 2 switching portion was extended as much as possible into the network. So, now routing can be performed at wire speed, and is performed at both the distribution and core layers. So distribution switches are configured as layer 3 gateways using switch virtual interfaces or SVIs or routed ports. And then routed ports are usually implemented between the distribution and core layer. Inter-VLAN routing and switch virtual interfaces. So the SBI is a virtual interface that is configured within the multi-layer switch. So to provide the gateway for a VLAN so that the traffic can be routed into or out of that VLAN, to provide layer 3 IP connectivity to the switch, so to support the routing protocol and bridging configurations. The advantage of SBIs are it is faster than router on a stick, no need for external links, switch to the network for routing, and not limited to one link. Layer 2 Ethernet channels can be used to get the more bandwidth. So, inter-VLAN routing and routed ports. So, a routed port is a physical port that acts similarly to an interface on a router. So, it is also not associated with particular VLAN. It does not support sub-interfaces. The routed ports are primarily configured between switches in the core and distribution layer. So, no switch port interface command on the appropriate port to configure a routed port. So, note that the routed ports are not supported on Catalyst 2960 series switches. Switching in layer 3 switch configuration issues. To troubleshoot layer 3 switching issues, check the following: the VLANs, the SBIs, the routing, and the host. So, in VLANs, you have to verify the correct configuration. In SBIs, you have to verify the correct IP, subnet mask, and VLAN number. And then in routing, verify that either static or dynamic routing is correctly configured and enabled. So, the host, in host, verify correct IP, subnet mask, and default gateway.